Alright, today we're going to talk about parallel lines and proportional parts in triangles. We've kind of already done this lesson before. I think we already have these notes. I went on ahead and color-coded the triangle segments for you to show you the relationships within the examples that were given. But the theorem just says if a line is parallel, and I've highlighted parallel in yellow and marked the arrows on the diagram, they're parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional length. So if you want to take the time out to color code it, you can. That is completely your choice. Okay, looking at example 1, since the arrows are marked showing that they are parallel, intersecting at two distinct points, the ratios can be set up in different ways, but still end up with the same answer. So I'm going to set it up x to 1 equals 8 to 2. We're going to set it up as an equation next. So cross multiply, I get 8 equals 2x, and then divide both sides by 2, so x equals 4. For example 2, same situation where the arrows are given, so the lines are parallel. Different ways you can set this one up. What I'm going to do is put 3 to 4 equals, and I went this direction, so I want to set it up going this direction as well. So I'm going to put 5 plus x to 8 plus x. To solve this one, we're going to have to cross multiply and use the distributive property. So we're going to have 3 times 8 plus x equals 4 times 5 plus x. Distribute, we get 24 plus 3x equals 20 plus 4x. And then after we put variables on one side and constants on the other, what I'm going to do is put the variables on the right and the constants on the left. So we now have 4 equals 1x. Alright, looking at example 3, which we're starting to see the similarities in the examples. Parallel lines. So I'm going to put x plus 1 to 6 equals x to 4. Your setup may be different than mine, but that's okay. Cross multiply, and if you need to circle it, you can. So now I have 6x equals 4x plus 4. Since we have to solve for x, then I want to put the variable on this side. If I cross the line, I got to change the sign. So 2x equals 4. So what number times 2 gives you 4? X equals 2, for example 3. Looking at example 4. And again, you can go left to right. We can go top to bottom to set it up. For this one, I'm going to do 9 to 6. And then the question is, can I put two different variables together? No, I can't. So I want to make sure I've read all the instructions, because it does say the distance of r to t is 10. So from here to here is 10. So 6 plus what gives you 10? That means y is going to be 4. Now I can go back and set up my proportion, because I cannot have two different letters in it. So I'm going to do 9 to 6 equals 2x minus 1 to 4. Cross multiply, I've got 9 times 4 is 36. 6 times 2x is 12x. And then 6 times negative 1 is negative 6. Since I only have one variable, I'm going to keep it on the side that it is at. And then I'm going to take the negative 6 to the other side. When I cross the line, I got to change the sign. So now I have 42 equals 12 times x. Divide both sides by 12. So we have x equal to 3.5. Okay, on the next page, we have another theorem. So we can prove converses, which is the conditional flipped. This theorem says if a line intersects two sides of a triangle and separates the sides into corresponding or same position segments of proportional lengths, then the line is parallel to the third side. So in example 5, it says in triangle EFG, the length of EG is 15. The length of EH is 5. The length of LG is 12. And the length of FL is 6. Our goal is to determine whether or not line segment HL is parallel to EF. So we are going to do 5 to 6 equals, and we're going to do 10 to 12. So the question is, where did we get the 10? Well, if you come back and look at the length, we were missing HG. And so if the total length is 15, 15 minus 5 is 10. So the length of HG is 10. If you need to go as far as setting it up or writing out some labels, we have EH to FL, and then we have HG to LG. So if I were to cross multiply, I get 60 both ways. If I were to reduce 10 to 12 to see if they share a common ratio, I've got 5 to 6. So I'm going to reduce the 10 to 12 by 2. They share a common ratio. So yes, they are parallel. Alright, in example 6, our goal is to find x so that we can prove that line segment DE is parallel to line segment CB. So do we have enough information? Do we need to have maybe take the information we're given and find additional numbers that we need? So the distance from A to C is 30. The distance from A to E is 22. The distance from E to B is x plus 4. And the distance from A to D is 10. So do we have enough information? Almost. We still need the distance from D to C. And to get that, we're just going to have to subtract 10 from 30. So the distance from D to C is 20. So now we have enough information to set up the proportion. And I'm going to do 10 to 22. And then I'm going to do 20 to x plus 4. So 10 to 22 equals 20 to x plus 4. If I cross multiply, I'm going to get 10 times x plus 40 equals 440. And since I have only one variable to worry about, I'm going to subtract 40 from 440. So 10x equals 400. And then what number times 10 gives you 400? So our answer is going to be x equals 40. Alright, so we're on to our third theorem of the notes. A segment whose endpoints are the midpoints, keyword being midpoints, of two sides of a triangle is parallel to the third side, and its length is half the length of the third side. Looking at example 7, I think the marking should help us set it up. But just don't forget that when we set up a proportion, we can't have two different variables in the proportion. So to solve for y, I'm going to do 4y plus 6 equals 2y plus 18. Since I have variables on both sides of the equation, My goal is to bring the 2y to this side, so that means I'm going to have to take the 6 to the right hand side. So if I subtract 2y from 4y, I am left with 2y. And since I have to go to the opposite side, I'm going to take 6 away from 18, and that leaves me with 12. So for this problem, y equals 6. Since we've solved for y, our other job for the instructions say to solve or find the value of x. So we are going to see if we have enough information, and we do. So we've got that one parallel to that one. Now, the only difference is in the theorem, it does say that it is half the length of the third side. So we are going to have to double that half to set it equal to that third side. So that information there is what's going to get you through those problems. Since I'm going to have to distribute the 2, I've got 8x minus 10 equals x plus 11. Since I have variables on both sides, I'm going to take the x to this side. And that means that I'm going to have to take the negative 10 over here. Cross that line. I got to change that sign. So now I have 7x equals 21. And what number times 7 gives you 21? X equals 3. Alright, we're on the last example of today's notes. It is very similar to example 7 where they want us to find the values of x and y. So we're going to start with solving for y. Since it is at the midpoint, they are equivalent, so I'm going to set 2y plus 18 equal to 5y minus 3. Since I have variables on both sides of the equation, I'm going to look at it. I'm going to put the 2y over here, just so I can keep my variables positive. Negative 3 goes to the other side. So if I add negative 3 and then bring it over, I had to add 3 to 18, so I've got 21 equals. Taking 2y away from 5y, I'm left with 3y. So what number times 3 gives me 21? I've got y equals 7. Now to solve for x, since it is half the length of the third side, I need to double the smaller one. So I'm going to do 2 times 5x minus 2 equals 72. We will need to distribute the 2. So now I have 10x minus 4 equals 72. The negative 4 needs to go to the other side since we only have one variable. So 10x equals 76. It's okay to have decimals. So x equals 7.6. Hope this helps since I'm not there. Sorry I couldn't be there, but hopefully this will help get you through the notes and the assignment.